We're now beginning to talk about trigonometric ratios, and we have three trigonometric ratios, which are the sine, the cosine, and the tangent. And the sine, cosine, and tangent are all ways of relating sides of right triangles to each other. Sine is equal to the opposite side over the hypotenuse, cosine is equal to the adjacent side over the hypotenuse, and tangent is equal to the opposite over the adjacent. This is commonly remembered using the spelling SOHCAHTOA, which is SOHCAHTOA. Now I can never remember how to actually spell that, so what I've come up with is a memory device, which is some old hippie caught another hippie tripping on acid, and that is an easier way to remember how to spell that word. Now the reason why we need to know that is because whenever I'm asked to find something like the cosine of C here in this problem, I have to look at angle C, and the first thing that you'll need to do is label the triangle relative to that angle. So we have three labels that we can use. We can use the opposite, we can use the adjacent, or we can use the hypotenuse. Those are the only three labels that we could use. So we say relative to C, opposite of it would be across from it, which is the 20 in this case. The hypotenuse is always across from the 90-degree angle, so that's got to be the 25. It's also the longest side of the triangle, and that leaves the 15 left to be the adjacent side. Now, if I'm looking for cosine, that means I'm going to have to use the CAH, the caught another hippie part of the phrase. So I would say cosine of the angle is C is equal to the adjacent side, which in this case is 15, over top of the hypotenuse side, which in this case is 25. Now I can reduce that and say that cosine of C is equal to, and 15 over 25 would reduce down to 3/5. And this would be my final answer for this type of problem. Now, unfortunately, that's not the only type of problem that can be asked. For instance, I could look at the next type of problem, which is you're given a right triangle, any right triangle. It doesn't really matter what it is. This is a nice, simple one. And you're asked to find a missing side, but you're not given two sides. Usually you'd use the Pythagorean theorem for something like that. But right now we only have one side, which is the 19. We're asked to find the x. But luckily we do have this 40-degree angle in here. So we're going to use the trigonometry to find the length of x, and we need to label it based off the angle that we know. So that is 40, so therefore x is the opposite side of 40. The hypotenuse is across from the 90-degree angle, and that leaves the 19 left for the adjacent side. Now what we need to do is figure out which function we're going to use. Well, we obviously need to find x, so we're going to have to use the opposite side, and we know the 19, so we're going to have to use the adjacent side as well. So if I look back at my thing, some old hippie caught another hippie tripping on acid, the function that uses the opposite side and the adjacent side is the tangent function. The other ones use either the opposite or the adjacent, but not both of them. So the one function that the only function I can use would be the tangent function for this problem. So we say tangent of the angle, which in this case is 40, the angle always goes next to the tangent function, is equal to, and then we just say, well, that is opposite over adjacent, so that would be x over 19. Now, there's many ways that you can do it from this part. You can leave the tangent 40 as tangent of 40, or you can calculate out what tangent of 40 is, and if you're going to do that, you need to make sure that your calculator is in degree mode, not in radian mode. And tangent of 40 is equal to 0.8391. 0.8391 would then be equal to x over 19. Now this is a simple problem to solve. You just got to get rid of the 19 to get x by itself. I like to just set up a cross multiplication problem. It makes it always nice and simple. 1 times x is just x is equal to, and then we have to multiply the 19 times the 0.83, and that'll get me 15.94. So the length of x is 15.94 units. Now that's not the only thing that we can use for trigonometry. We can also find missing angles when we're given the sides. For instance, this one right here, we have a side and another side, but we need to find the size of this angle. So what we want to do is label the triangle again. Relative to the angle, this is the opposite side, which I don't really give a crap about, and relative to the 90-degree angle makes this the hypotenuse, the 31, leaving you the 15 to be the adjacent. Now, if I remember my ratio, some old hippie caught another hippie tripping on acid. I am looking at the two sides, the adjacent side as well as the hypotenuse. And the only one that uses adjacent and hypotenuse is the cosine function. So we're going to have to use cosine of the angle. But I don't know the angle. The angle is a question mark, so I'm going to have to say cosine of x. Cosine of x is equal to the adjacent side, which is 15, over the hypotenuse, which is 31. Now, this is an interesting problem because now I have all the fraction part, but I don't have the thing on the inside of the cosine function. I can't calculate that using a calculator. So what I have to do is somehow manage to break this cosine piece off of the x, but the x is kind of attached to that. It is cosine of x. So what we're going to have to do is use what is called the inverse function. The inverse of a cosine function is the cosine inverse, and it is given by cosine to the -1, which is usually found second cosine on whatever calculator you're using. However, cosine inverse, if I do it on the left side of the equation, I also have to do it on the right side of the equation as well. So then I just have to calculate, and that'll get me x is equal to, and I type in my calculator, cosine inverse of 15 divided by 31, and that will get me, that'll get me 61.06 or 61.1 degrees.